Good morning. This is Miss Billerbeck, and we're going to talk about 9.1 tables, charts, and graphs. So we're going to use the chart on this page, 33, and we're going to look at how to find the flying distance from Miami to Las Vegas. Okay, so let's take a look at Miami to Las Vegas. All right, so looking at this, we see, okay, so we have Miami. Okay, so Miami here, and then LAS is Las Vegas. So that's 2,170 miles. So we're going to write 2,170 miles. Okay, then it asks, well, how about from Atlanta to San Diego? So we're looking at Atlanta. Here's Atlanta and San Diego. Okay, so it says from to, so Atlanta to San Diego. So that's 1,890 miles. Okay, so then it says, well, how much shorter is the distance in the journey if we go from Atlanta to San Diego via Phoenix? Now that doesn't make any sense that it'd be shorter if you stop at another city, but let's just humor them. So Atlanta to Phoenix is 1,580 miles. So 1,580 miles. Okay, now we're at Phoenix Airport and we're going to San Diego. So Phoenix to San Diego is 304. So 304. Okay, so let's see what the magic numbers say. Okay, so let's learn something here. Okay, so 1,580 plus 304 is 1,884. And the question was, how much shorter is the distance if we go from Atlanta to Phoenix and then to San Diego? And it's so we subtract this, well, 1,890 minus 1,884 is 6 miles shorter. Can you believe that? I can't. It must be that, you know, the flight plans and stuff have the planes going way away from, you know, big airports if they're going from Atlanta to San Diego. So that's kind of interesting. I would have thought the direct flight would be the shortest, but apparently not. All right, so let's look at the next slide. So we're just learning how to read charts is really important because, you know, when we travel, we read maps and things like that. So, and we have to be able to read tables and statistics where we'll try to make decisions. So that's what this chapter is about. Okay, so now we're going to depict some data. We're going to graph it, we're going to read the graph, and then we're going to try to figure out from this graph some areas that weren't just told to us, okay? We have to do a little thinking. Okay, so this is the data that was given to us. So we have miles and kilometers. All right, so we need to set up one axis for one thing. So let's set this one up for miles. So this one's miles, which is the x, because they gave us x. And then we're going to do kilometers on this one, which is y. Okay, so we usually do y here and x here because x is independent toward the input and y is dependent or the output. All right, so we're going to 10 here. So 1, 2, 4, 5, 6, 7. So we're going to have to do 2, 4, 6, 8, 10. Okay, and this one we're going to 16, and we have about 10 of these. So we're going to also call each one of these 2. So if this is 4, this is going to be 8. This is when knowing your factors really helps. 12, 16, and then we have 20 up here. All right. So let's graph a few of these, see what we have. So the first one we have 2, and it's about 3 1/4. So that's 2, 3 1/4 is right around there. 4 and 6 1/4, or 6 1/2. So 7's there, so a half's probably right about there. 6 is almost 10. So it is right about here. 8 is at 12 1/2. It's super close to 13, so it's right about there. And then 10 is a little past 16. So 16's there and 10's there. And wow, look at that data. That's pretty linear. Let's draw the line. Okay. Okay, so we have a line there. Okay, so if we read the data, we want to read, well, what is it at 9? So 9's right here, and 9 right there. Well, this is 14. That's about 14 1/2. 14.5, and these are miles. Okay, 5 kilometers. Oops, sorry, I read it wrong. Ooh, don't do that. Okay, I read the miles and we're doing kilometers. See how I did? I made a big mistake. Don't do that. Oof. This is miles. We're trying to find it. Okay, so we go from 9 kilometers here. So 9 is here, and then that gets us right here. So then we need to find out what the miles are, which is here. So that's 5 1/2 miles. That makes much more sense. 5 1/2 miles. Because I was thinking, wait a second, a 10K is only 6 miles. So that's what kind of told me we were off, because 9K would be less than 6 miles. Okay, so 5 is right here, and 5 hits here, which is about 3. So 5K is 3 miles, which makes sense because 10K is 6 miles. It's about 6 miles. See how that is? Okay, that's why we do 10K races. So what's the slope? Well, I think we should go with the slope right here. So we have a rise of 5 and a run of 3 right here. So our slope triangle is a rise of 5, and we rose 5 and ran 3. That's our slope triangle right there. Okay, so the slope then is 5 over 3. So what would be the equation? Well, the y-intercept is at 0. So our equation for this would be y equals 5 thirds x plus 0. But we really don't have to write plus 0, so we can just write 5 thirds x, because our rise was 5 and our run was 3. Yep. Actually, it was a little more than 3, but wait, 5K. Oh, that's 6K, that's why. Okay, so 5K goes right here, which is 3. There we go. Perfect. All right, so that's how I got 5/3 x. So if we keep going up, it'll be 5/3 x, 5/3x, the whole time on this line. All right, so that's how you do it to depict real life data. All right, and this is how we predict things, by using charts and graphs and knowing how to do equations, so we can predict things that might be just a little bit off the graph, not too much, because sometimes the data can get distorted really far away from our general data. So we want to stick close to the data we have when we're predicting. All right, that's it for this lesson. It was very short. Have a wonderful day. Bye-bye.